Good evening. Sum number 11. If numbers are formed using digits 2, 3, 4, 5, 6 without repetition, how many of them will exceed 400? Write down. I'll dictate the solution. Available digits are, start writing. Available digits are 2, 3, 4, 5, 6. Full stop. Next line. Repetition is not allowed. Repetition is not allowed. Repetition is not allowed. And number should be greater than 400. And number should be greater than 400. Okay, see on the screen. First case, in fact, there are 3 cases. It can be 3-digit number, 4-digit number, 5-digit number. Every 4 and 5-digit number will be greater than 400. But not all 3-digit numbers will be greater than 400, right? So write down. First case, 3-digit numbers. Write down. Here, hundreds place can be filled. Here, hundreds place can be filled. F-I-L-L-E-D can be filled in 3 ways. In 3 ways. In 3 ways. Inside the bracket, write down. Using 4, 5 or 6, bracket complete. I hope you are getting this. See, number has to be greater than 400, right? And therefore, hundreds place can be filled in 3 ways. Next line. Tens place can be filled in 4 ways. Tens place, T-E-N''S. Tens place can be filled in 4 ways. And units place in 3 ways. And units place in 3 ways. Therefore 3 into 4 into 3 equal to 36 such numbers can be formed. 3 into 4 into 3 equal to 36 such numbers can be formed. Number 2, 4-digit number. 4-digit numbers. Here, thousands place can be filled in 5. Here, thousands place can be filled in 5, comma, hundreds place in 3. Hundreds place in 3. I'm sorry. I'll repeat this part. Here, thousands place can be filled in 5, comma, hundreds place in 4, not 3, hundreds place in 4, comma, tens place in 3, tens place in 3, and units place in 2 ways. And units place in 2 ways. Therefore, 5 into 4 into 3 into 2 equal to 120 such numbers can be formed. 120 such numbers can be formed. See, this is not at all difficult. Repetition is not allowed, that is why. And every 4-digit number is definitely greater than 400. Third case, 5-digit numbers. Five-digit numbers. In that write down. Here, 10,000s place. Here, 10,000s place can be filled. Here, 10,000s place can be filled in 5, comma, thousands place in 4, comma, hundreds place in 3, comma, tens place in 2, and units place in 1 way, because only 1 digit is left, and units place in 1 way. Therefore, 5 into 4 into 3 into 2 into 1. So again, 120. 120 such numbers can be formed. 120 such numbers can be formed. Next line. Thus, total numbers greater than 400. Thus, total numbers greater than 400 equal to 36 plus 120 plus 120 equal to 276. 276. Sum number 12. Just listen to me carefully, but please do write the solution after the lecture. This is how you have to write the explanation. How many numbers formed with digits 0, 1, 2, 5, 7, 8 will fall between 13 and 1000 if digits can be repeated? Now degree of difficulty is increased because one of the given digits is 0. So digits are 0, 1, 2, 5, 7, 8. The numbers between 13 and 100 are 2-digit numbers, right? The repetition of digits is allowed. So using 1 at tens place. Okay. Tens place can be filled by using 1 in 1 way. Units place can be filled by any one of the digits 5, 7, 8 in 3 ways. Therefore, total number of 2-digit numbers equal to 1 into 3 equal to 3. Right? See, why to say this? Between 13 and 1000. You may also say those numbers are what? 13 cannot be considered. Can we consider 15? We can consider 17 and 18. Yes, 3 numbers. Okay. Now the next part, using 2, 5, 7, 8 at tens place. Tens place can be filled by using 2, 5, 7, 8 in 4 different ways. After this, the units place can be filled by any one of the 6 digits in 6 different ways. So total number of 2-digit numbers equal to 4 into 6 equal to 24. I repeat this part. See, actually 6 digits are given. 0 cannot be there in tens place in a 2-digit number. We have already considered the case in which 1 occurs in tens place, and that is why I am considering that this place, tens place, is either 2 or 5 or 7 or 8. Okay, so 24 such numbers. That is why degree of difficulty is increased. Second part, the number between 99 and 1000 are 3-digit numbers. The repetition of digits is allowed. So units place can be filled in 6 ways. Tens place can be filled in 6 ways. Hundreds place cannot be filled in 6 ways, because if 0 occurs there, it will not be a 3-digit number, it will be a 2-digit number, right? So hundreds place can be filled in 5 ways. So there are 5 into 6 into 6 equal to 180 numbers. Hence the total numbers formed with digits 0, 1, 2, 5, 7, 8 between 13 and 1000 is 3 plus 24 plus 180, that is 207. Sum number 13. A school has 3 gates and 4 staircases from the first floor to the second floor. How many ways does a student have to go from outside the school to his classroom on the second floor? This is a straightforward sum. 3 into 4, 12, isn't it? Okay, write down. 3 gates to enter the school. Write down. 3 gates to enter the school. Full stop. 4 staircases to go from first to second floor. 4 staircases to go from first to second floor. Four staircases to go from first to the second floor. Therefore, the number of ways equal to number of ways equal to 3 into 4 equal to 12. Sum number 14. How many 5-digit numbers form using the digits 0, 1, 2, 3, 4, 5, which are divisible by 5 if digits are not repeated? Now digits to be used are 0, 1, 2, 3, 4, 5. 5-digit numbers which are divisible by 5 are to be formed. The repetition of digits is not allowed. For a number to be divisible by 5, the units place can be filled either by 0 or 5. So we have to consider 2 cases. First case, using 0 at units place. So this place can be filled in 1 way. 10,000s place can be filled in 5 ways, because 0 is utilized, repetition is not allowed, and in any case we cannot have 0 in 10,000s place in a 5-digit number, right? So 10,000s place can be filled in 5 ways. Thousands, hundreds, tens places can be filled by remaining 4 digits in 4, 3 and 2 ways respectively, because repetition is not allowed. So 5-digit numbers which are divisible by 5 equal to 5 into 4 into 3 into 2 into 1, that is 120. Then using 5 at units place. So in that case, 10,000s place cannot be filled in 5 ways because 0 cannot occur there. So 10,000s place can be filled in 4 ways. Now we are left with 4 digits because out of 6, 2 are utilized. So thousands, hundreds, tens places can be filled by remaining 4 digits in how many ways? 4, 3 and 2 ways respectively. So 5-digit numbers which are divisible by 5 equal to 4 into 4 into 3 into 2 into 1 equal to 96. Hence, the total number of 5-digit numbers which are divisible by 5 equal to 120 plus 96, that is 216. We cannot start permutation directly. Before that, we have to discuss an important notation, factorial notation. If n is a natural number, then the product 1 into 2 into 3 into 4 up to n, what will be the number before n? N minus 1. Okay. In short, product of first n natural numbers is called factorial n or n factorial. This is the most popular notation, n exclamatory mark, or you may use this notation also to represent factorial, n factorial. Okay. So what is n factorial? N factorial is product of, don't say n natural numbers, otherwise 7 into 11 into 15 is not 3 factorial, or 3 into 4 into 5 is again not 3 factorial. First, it has to begin with 1. So the product of first n natural numbers is n factorial. 0 is not a natural number, but 0 factorial is defined to be 1. I can prove this, but not now. Once we complete, once we discuss permutation formula, I can tell you the logic for this. Okay. So what is 1 factorial? 1 factorial is product of first one natural number, that is just 1. What is 2 factorial? Product of first two natural numbers, it is 2. What is 3 factorial? It is 1 into 2 into 3, but 1 into 2 is already obtained. So I'll just say 2 into 3, that is 6. What is 4 factorial? Product of first 4 natural numbers, 1 into 2 into 3, which is 6, into 4, that is 24. Similarly, what is 5 factorial? 1 into 2 into 3 into 4 into 5. So 24 into 5, that is 120. 6 factorial, product of first 6 natural numbers. So 120 into 6, that is 720. You are expected to remember at least till 7 factorial, product of first 7 natural numbers. So 720 into 7, that is 5040. Okay. So this is about factorial. Now, next part is again very important. See, n factorial is 1 into 2 into 3 up to n. So term before that, as I said, is n minus 1. Now consider this part. This is product of first n minus 1 natural numbers. So can I say n factorial is n minus 1 factorial into n? Yes. Now this result is very important. How to put this in words? Factorial of any number is factorial of 1 less multiplied by that number. Similarly, factorial of any number into immediately next number is factorial of next number. Is that clear? See, this helps in simplification part. For example, 73 factorial upon 72 factorial. Will you say, first I will obtain numerator, then denominator and simplify? No. 73 is greater than 72. So 73 factorial is 72 factorial into 73 upon 72 factorial. We can cancel this to get 73. In fact, we can use this result repeatedly. Means what? Suppose it is 10 factorial upon 7 factorial. I hope you will not cancel this exclamatory mark to write 10 by 7. That is absurd. Which is greater? 10. So factorial of greater can be expressed as factorial of smaller. How? Basically, what is 10 factorial? 1 into 2 into 3 into 4 into 5 into 6 into 7. That is 7 factorial. Into 8 into 9 into 10. Denominator as it is. So working rule is very simple. Factorial of greater is factorial of smaller. Go on adding 1 unless you get greater. You can verify. I hope you will not say 7 factorial into 8 factorial, 9 factorial, 10 factorial. No, 8 into 9 into 10. Now cancel this. So 720 is the answer. Okay. So this is very important. Now see this. Properties of factorial notation. I have already explained this. The factorial, second note, the factorial of a negative number or a rational number which is not an integer is not defined. The factorial is defined only for whole numbers. Why say whole number? Because 0 is not a natural number. So, but still 0 factorial is defined to be 1. That is why whole number. If x factorial is y factorial, then x equal to y, provided x not 0, y not 0. Okay. See, 0 factorial is 1 factorial. So, can we say 0 is 1? No, we can't. Again, I hope you will not open the bracket. This is, see, if you read this as p plus q into factorial, you might open the bracket and say p factorial plus q factorial. This is absurd. P plus q factorial, p plus q factorial cannot be simplified. Similarly, this part, I hope that you will appreciate this. P upon q factorial is not p factorial upon q factorial, right? Now, I hope you understand this. P plus q factorial is always divisible by p factorial as well as q factorial. The reason is simple. P and q are natural numbers. So 2 plus 5, say 7 factorial. 7 factorial is product of first 7 natural numbers. Naturally, it includes product of first 2 natural numbers. It includes product of first 5 natural numbers also. That is fine. Okay. So this is about factorial notation. In fact, I may also use this logic to prove 0 factorial is 1. Put n equal to 1. So 1 factorial equal to 0 factorial into 1. But 1 factorial is 1. So right hand side should be 1. Right hand side will be 1 if 0 factorial is 1. Right? But the better logic is using that formula for permutation. Exercise 3.2, evaluate. First question. 8 factorial product of first 8 natural numbers, 40,320. Then 10 factorial. You may also argue that we have already obtained 40,320. So we just multiply it by 9 and 10. That is 90. Absolutely right. But in exam, if only this is asked, they will have to find this. So what is the answer? 36,28,800. 10 factorial minus 6 factorial. You may say we have already obtained this. So we'll just subtract 720 from this. Absolutely right. But if only this is required, what will you do? That is why I have used this method. 10 is greater than 6. Factorial of greater can be expressed in terms of factorial of smaller. So what is 10 factorial? 6 factorial into 7 into 8 into 9 into 10. Less 6 factorial. Take 6 factorial common to get in bracket 7 into 8 into 9 into 10 minus 1. Now 6 factorial is 720. This product 50, 40 less 1. So this is the answer. Again 36,28,080. Fourth one is the simplest one. 10 minus 6 factorial. They want to see whether you write this as open the bracket 10 factorial minus 6 factorial. That is absurd. 10 minus 6 is 4. 4 factorial is product of first 4 natural numbers, which is 24. Second question. Again, you have to find the values. 12 factorial upon 6 factorial. I hope you won't cancel that factorial notation exclamatory mark. Again, you will not find these two separately. 12 factorial product of first 12 natural numbers, which include product of first 6 natural numbers also. So working rule is simple. I'll explain that part once again. Factorial of greater is factorial of smaller into, go on adding 1 unless you get greater. So into 7, into 8, into 9, into 10, into 11, into 12. Denominator 6 factorial as it is. Now I can cancel 6 factorial with 6 factorial. Now this product is 6,65,280. Second, 12 by 6 factorial. 12 by 6 is 2. 2 factorial is 2. Third, 3 into 2 factorial. That is factorial of 3 into 2. 3 into 2 is 6. 6 factorial is product of first 6 natural numbers, 720. 3 factorial into 2 factorial. 3 factorial is 6. 2 factorial is 2. 6 into 2, 12. Okay, fifth one, 9 factorial upon 3 factorial, 6 factorial. Basically, 9 is greater than both 3 and 6, but 6 is greater than 3. So 9 factorial is what? 6 factorial. Go on adding 1 unless you get greater. So 6 factorial gets cancelled. 3 factorial is 1 into 2 into 3. So result is 84. Here, which is greater? 6 is greater. So I take 4 factorial common to get 5 into 6 minus 1. Why? Because 6 factorial is 4 factorial into 5 into 6. As this is taken common, so 4 factorial gets cancelled. 30 minus 1, that is 29. Then 8 factorial upon 6 factorial minus 4 factorial. Numerator is 4 factorial. Go on adding 1 unless you get 8. From denominator, take 4 factorial common to get 5 into 6 minus 1. 4 factorial gets cancelled. 1680 upon 29. Don't simplify this further. Don't write this as rather in decimals. Let it be in this form, rational number. 8 factorial upon 6 minus 4 factorial. 6 minus 4 is 2. Now 2 factorial gets cancelled. 3 into 4 into 5 into 6 into 7 into 8. 20,160. Third one, write in terms of factorials. First part, 5 into 6 into 7 into 8 into 9 into 10. Will you say this is product of 6 numbers or 6 factorial? No, first 6, then only 6 factorial. So we multiply and therefore we have to divide by 1 into 2 into 3 into 4. So that numerator becomes product of first 10 natural numbers. Naturally, it is 10 factorial. What is denominator? Product of first 4 natural numbers, 4 factorial. Second, 3 into 6 into 9 into 12 into 15. 3 is 3 into 1, 6 is 3 into 2, 9 3 into 3, 12 3 into 4, 15 3 into 5. 3 into 3 how many times? 5 times. So 3 raised to 5. into 1 into 2 into 3 into 4 into 5. Product of first 5 natural numbers, 5 factorial. Third is similar to the first. Multiply numerator and denominator by what? 1 into 2 into 3 into 4 into 5. So denominator becomes 5 factorial. Numerator becomes product of first 9 natural numbers, which is 9 factorial. Simple. Fourth is again similar to second. 5 is 5 into 1, 10 is 5 into 2, 15 is 5 into 3, 20 is 5 into 4. 5 raised to 4, 1, 2, 3, 4. 4 factorial. Fourth one, evaluate n factorial upon r factorial into n minus r factorial for, see, this is formula for combination. We are going to prove this. Okay, n is 15, r is 10. So 15 factorial upon 10 factorial into 5 factorial. Listen to me. I omitted one step. 15 is greater than 10. So what is 15 factorial? 10 factorial into. So 10 factorial gets cancelled. That is why you cannot see 10 factorial here. So what remains is 11, 12, 13, 14, 15. So it's a matter of practice. And what is 5 factorial? Don't wait for this that it will get cancelled. 5 factorial has to be written as 120. Now simplify. So 3003. Here 15 factorial upon 8 factorial into 7 factorial. 15 is greater than 7 and 8, but 8 is greater than 7. So 15 factorial is 8 factorial into. Go on adding 1 unless you get 15. So 8 factorial gets cancelled. 9, 10, 11, 12, 13, 14, 15. 7 factorial. I know the value 50, 40. So substitute that value and tell me what is the answer. 6, 4, 3, 5. Fifth question. Find n if first part n upon 8 factorial equal to 3 upon 6 factorial plus 1 factorial upon 4 factorial. Some students say, sir, we will write factorial value for each and then we'll simplify. That is also correct. But why to do that? See, 6, 4 and 8. 4 is the smallest. So we will express factorial of remaining 2 in terms of 4 factorial. So this is equal to 3 upon 6 factorial is 4 factorial into 5 into 6 plus 1 upon 4 factorial. If you take 1 upon 4 factorial common, you get 3 upon 30. That is 1 by 10 plus 1. Now what is 8 factorial? I omitted one step. 8 factorial is 4 factorial into. Now 4 factorial gets cancelled. Into what? 5 into 6 into 7 into 8. This is LCM 10, 11 by 10. Now what is n from this? 5 into 6 into 7 into 8 into 11 upon 10. Simplify to get 1848 as the value of n. Second, n upon 6 factorial is 4 upon 8 factorial plus 3 upon 6 factorial. Now 8 factorial is 6 factorial into 7 into 8. Take 1 upon 6 factorial common and then it gets cancelled with this 6 factorial. So what remains in bracket is 4 upon 56, that is 1 by 4 plus 3. LCM 14. So 1 plus 42, that is 43 upon 16. This is already cancelled. So what is n? 43 by 14. So that's it for today.